In this chapter, you will learn about lighting in Unity. A few things have changed since version 5.4. The light settings are now in Window, Lighting, Settings. A visual reminder of the new location will appear later in the video, when the instructor opens the lighting menu. There are a few improvements to the lighting system. Later in the video, you'll hear this noise. At that point, the video will pause, and I'll chime in with information you should know.
In this chapter, we'll introduce light baking in the Unity editor. Lighting is very computationally intensive. It takes a lot of computing power to simply figure out the lighting in a scene, where it goes, and what it's bouncing on. Trying to do this in real time has historically been tough in games. In movies, we have render time. We can render out the scenes as long as they take and composite together. It's not real-time driven. In games, though, we need to do things in real time. And so we need to economize on our lighting, both how we calculate it and when we calculate it. So we have light baking. Right now in the scene, everything is dynamic. Everything is being considered in real time. What that means is that nothing is being pre-calculated. Light baking, then, is when we pre-calculate the lighting in a scene and store it, and then recall it when the game is being played. Although it looks like the scene is lit, baked lighting actually is calculated in. We're not doing any lighting calculations at the time of gameplay, and that saves us a tremendous amount of processing power. We can get to our lighting here in Unity by choosing Window and Lighting. In Unity, we use the Enlighten engine for light baking. And as we can see in here, we have settings for objects, any particular object that's selected. For the scene, global controls over environment lighting, pre-computed real-time global illumination, and baked global illumination, and finally our light maps. We have other settings available here as well for things like fog and final gather. And really, what this gives us is a lot of artistic flexibility, the ability to really fine-tune our lighting and our light baking so that not only is our scene lit, but the lighting is very thoroughly calculated and crafted for a certain mood. That when we play this game, we feel a certain way because of the lighting, and we've baked or stored that data as much as possible to reduce the computational load while crafting a certain look to the game. Unity supports real-time and baked global illumination. Global illumination is the bouncing of light off surfaces and color pickup from adjacent surfaces. Additionally, we can choose between real-time global illumination and baked, and also the option to build continuously. And this is a huge help when you're trying to design a level. What this means then, when we turn on auto here in our building, is that the Unity editor will continually try to calculate and keep pace with edits we're making, and keep that lighting up to date. We'll delve more into lighting in this chapter, and we'll get started by setting our objects for light baking, getting it set up so that things react correctly and bake properly.
In Unity 2017, we now have the progressive light mapper. You can enable this by going to the light mapping settings and changing from Enlighten to Progressive Preview. You'll see here that the option to enable the progressive light mapper is unavailable. This is because we need to allow baked global illumination. Go to Mixed Lighting and check Baked Global Illumination. Now we can adjust the light mapper setting and set it to the progressive preview. The progressive light mapper is a quick system that provides baked light maps and light probes with progressive updates in the editor. Essentially, using the progressive light mapper will allow you to test and iterate lighting in your scene very quickly. When you change your lighting to use the progressive preview, the settings will update. With Prioritize View checked, this will focus on what you're looking at through your scene view and update those elements first. You can choose direct and indirect samples used for calculating lighting. You can adjust the number of bounces. For most scenes, 2 should be enough, but indoor scenes may require additional bounces. Filtering allows you to configure the post-processing of light maps. I recommend keeping this on auto to use the default values. We also have settings to adjust the resolution and size, as well as a few items related to the mode of our lighting. If you're a technical artist, these settings may come in handy, but for general Unity developers, the default settings provided will do just fine.